4.3, trig extended. I don't know why this is the title, but it is.
Wait, units, like the full unit circle?
Yes.
No, half the. That's why I said extended.
Circular functions. Alright, so we have an angle. This is the initial side. This is my theta. And then this is the terminal side.
What? Yo, this sounds so cool. What?
To find coterminal angles for degrees, we do theta plus or minus 360 degrees. Those are the easy ones. For radians, we have theta plus or minus 2 pi. So a lot of times, the reason I said degrees are easier or whatever is because radians a lot of times obviously isn't just in pi, it's in 5 pi over 4 or something like that, and so we're having to get a common denominator to find coterminal angles. If they are values like on the unit circle, it's a little bit easier in my opinion to kind of count out the ones. If they're not, then a lot of times I end up just converting them to degrees or something like that. But whatever the value is, if it starts in radians, you've got to finish in radians. Starts in degrees, you need to finish in degrees. So the first one, say to identify one angle that is not coterminal with all the others. So they're going to give us a list of angles and we're determining what's coterminal and what's not. So we've got 5 pi over 3, negative 5 pi over 3, 11 pi over 3, negative 7 pi over 3, and 365 pi over 3.
We're answering in radians.
So what I would tell you is I would save 365 pi over 3 for last as far as trying to figure that one out. Because it's a pretty big number and I don't really feel like adding 2 pi that many times to get there. The other thing that would kind of be a cue to me is that both negative 5 pi over 3 and negative 7 pi over 3 both can't be coterminal. I just have to figure out which one actually is so that I can figure out which one is not, okay? Because they're too close together. They're only 2 pi over 3 apart, so that tells me that they can't both be coterminal with the other ones.
How far apart do they need to be?
2 pi.
Okay.
So essentially, I'm going to start with the first number, and I'm going to either add or subtract 2 pi and see where I get from there. Now, it could be that the instructions don't say, okay, we're seeing which of the 4 following are not coterminal with the first number. So the first number might be the one that's actually the problem, but I'll be able to figure that out pretty quickly when I use the first one to see. So I'm going to take 5 pi over 3, and I'm going to add 2 pi, but I need it over 3, so yep, I'm actually going to add 6 pi over 3. Well, that gives me 11 pi over 3, so right away I know that this one is good and this one is good.
So why did we do the 6 pi over 3 again?
It's 2 pi, so I'm adding or subtracting 2 pi to see what's coterminal.
Okay. And the question that is being asked right now is find coterminal angles?
Yeah, it says which, give the value of the angle theta. Oh, wait, I'm reading the wrong theta. That's the review problems. It says identify the one angle that is not coterminal with all the others. So one of these is not coterminal with all the other ones.
Okay.
So next thing I'm going to do, because, again, this is a pretty big number, I'm going to subtract 6 pi over 3 and see what happens. And then I may have to do it again. So 5 pi over 3 minus 6 pi over 3 gives me negative pi over 3. So that's also coterminal, but I'm going to have to, that's not one in my list. I'm going to subtract 6 pi over 3 again, and I get negative 7 pi over 3. So that tells me, since negative pi over 3 and negative 7 pi over 3 are coterminal, that tells me right away that this one is not. So then I would be able to say negative 5 pi over 3 is not coterminal.
Wait, why not? But 365 pi is coterminal?
Yeah, it will be. Because I know that one of them is not. And if I know that this one is not, then that means this one has to be. I just don't feel like adding increments of 6 pi over 3 to get to 365. However I could.
Okay.
You just keep adding and subtracting it till it gives you something that's wrong.
As soon as you get one that doesn't work, you know automatically. And so since this one is coterminal, it's not in my list, but I know this is coterminal because I subtracted 6 pi over 3 and got this. So then I was like, well, that's not in my list, but I have some that are more negative than that, so I subtracted it again. This one is coterminal. So since this one is between those, I know that there's not another coterminal one in between them. So I immediately can get rid of this one. Now, more often than not, when they're asking you about coterminal angles, they're going to give you an angle and they're going to say find a positive and a negative coterminal angle, and you're going to do so by adding or subtracting increments of 2 pi or 360 degrees, depending on the question. But if they give you a list of numbers, this is how you would go about finding them. So.
This is easy.
Point P is on the terminal side of angle theta. Evaluate the 6 trig functions for theta. If the function is undefined, write undefined. So number 8, the point is negative 4, negative 6. Okay, so I'm going to basically put this point on a graph. I don't need to be like, I'm not like doing anything like super crazy with that. I'm figuring out where that is and then evaluating all of the trig functions for theta. So I'm going to just set up a little graph here. I know that this is in quadrant 3. So I'm basically just going to draw my angle there. And it's going to form a triangle here. It always touches the x-axis, not the y. So that's how you know what your theta is. So then I have negative 4, negative 6. So that means that this is negative 4. This is negative 6.
That is not drawn to scale.
Okay, Shepard.
So then I need to find the hypotenuse of that. So c squared, or I'm just going to say c, is equal to the square root of 36 plus 16, just using the Pythagorean theorem. So c is equal to the square root of 52. So then my next thing would be, can I break this down any farther?
I don't know. 2 and 26, 13 and 2. 2 squared root of 13. Oh my
Yep.
gosh.
So c is 2 root 13. And then now I'm going to find all 6 trig functions for that theta value. All right, so what's sine of theta?
Opposite. It's negative 6 over 2 root of 13, which is negative 6 root 13 over 26.
So I would probably go ahead and reduce first just to make it easier. If not, then where you just got to, you'll just have to reduce it after. And that's fine.
Okay.
It will have to be reduced down. So 2 goes into 6 3 times. So then we would have negative 3 root 13 over 13. All right, what about cosine?
Negative 4 over 2 root 13, which is not that because we have to do the other stuff, but I don't want to.
All right, so 2 goes into 4 2 times, and then we just need to rationalize it. So negative 2 root 13 over 13. And then what about tangent?
Negative 6 over 4. 3 over 2.
So they're both negative, so it's going to become positive and then reduce to 3 over 2. Cotangent,
-2/3.
positive.
Positive.
So part of the reason that I went ahead and reduced in the first step instead of waiting till I was done is that way I can now just go ahead and use the reduced form for sine and cosine to get cosecant and secant. So what is secant?
Root 13 over 2.
Negative.
2.
Yep, negative root 13 over 2. And the negative can go on the top, bottom, in front, wherever. And cosecant,
Wait, why is 13 negative?
I just said the negative can go on the top, the bottom, or in front. It does not matter. Cosecant,
Root 13 over 3.
negative. Um, 10. The point is -3, 0. So where's this?
On the x-axis.
So it's going to be over here. So what do you think might have to happen?
Undefined.
Yep, it's undefined. And there's nothing I can do with that one then.
Okay. Sure.
All right, state the sign, positive or negative, not like, yeah, anyways. For the sine of t, cosine of t, and tangent of t for the given t values in the interval. So 14, we have the interval of pi over 2 to pi. And so we're looking at sine, then cosine, then tangent, where they are positive or negative. So in between pi over 2 and pi is sine positive or negative?
Positive.
Positive. What about cosine?
I don't know why it's positive.
Wait, hold on. I can do this.
Well, it's quadrant 2.
Oh, so it's negative. Wait, quadrant 2?
Yeah.
All right, look. Quadrant 2 is up here.
Yeah.
So sine is y.
Mm-hmm.
So that's positive. Cosine is x. So that's negative. So then what about tangent?
Tangent is x over y,
Tangent
so it's
is
negative.
Negative.
Wait, so what is the ordered pair? What is that?
It's not. It's an interval.
Yeah, Dana.
Okay.
Okay.
Oh,
Daniel,
it's
I
pi
don't
over 2,
understand
not pi over
that.
4.
Right, Andy?
16. 3 pi over 2 to 2 pi. What is sine?
Okay.
Negative. What is cosine?
Positive.
Positive. And tangent?
Negative.
Negative. If these are opposite, then tangent has to be negative.
How do we know what quadrant it's in? Is it because you tell us or?
Well,
Your
it's-
unit
it's
circle?
Like right here is 3 pi over 2, and there's 2 pi, so it's
Oh,
4.
0.
Never mind. I like your shoes on.
Why are you so?
Argumentative?
Yeah.
Because I'm gonna
Remember what you said on the way to art?
Oh, because you were being mean to me.
How?
All right, determine the sign, positive or negative, of the given value without a calculator. All I care about is if it's positive or negative. I'm not solving it. 18. The tangent of 192 degrees. So what quadrant would that be in? 1, 2, 3, or 4?
Third.
3. So is it positive or negative?
Negative.
Positive.
Positive because it's double negative.
Both things are negative, so it's positive. 20. Tangent of 4 pi over 5. What quadrant is that in?
I don't even know where 4 pi over 5 is.
Well, is 4 pi over 5 bigger than a half? So that means it's got to be over here.
Negative third.
And it's less than 1, right, as a fraction.
Yeah.
So what is tangent in quadrant 2?
Negative.
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 Basically said the wrong answer.
I heard. All right, choose the point on the terminal side of theta.
There's a point on the terminal side of theta.
22. Theta is equal to 2 pi over 3. And then they give us options. A is the point negative 1, 1. B is the point negative 1 root 3. And C is the point negative root 3, 1. And so I'm deciding out of these 3 points which one is on the terminal side of theta. So essentially I'm looking at equivalent values here. So if I look at my, so look, x, y, x, y, x, y. So based on what I'm given, that means I'm going to have to be looking at the tangent values. Okay, so y over x to determine this. Okay, so I'm trying to find which value of these of the tangent, it would give me an angle of 2 pi over 3. Okay, so tangent of theta would be equal to 1 over negative 1. Here, tangent of theta would be equal to root 3 over negative 1. And here, tangent of theta would be equal to 1 over negative root 3.
It's B.
Okay, so at 2 pi over 3, tangent is negative root 3. So that means it has to be this one here. So this has to be the point that it is.
And to find tangent, it's always y over x instead of, okay.
Yep.
Y over x.
Now, over here, just notice if this was, say, instead, if it was 5 pi over 6, I would have to rationalize this to be negative root 3 over 3 to get that, to see it on the unit circle. Okay? So just make sure you pay attention to that because our values are all rationalized on our unit circle. So just make sure you're aware of that. Do you want to see another one of these?
I think
Yes.
we're set.
All right, 24. Theta equals negative 60 degrees. A is negative 1, negative 1. B is 1 negative root 3. And C is negative root 3, 1. So again, I'm going to be looking for tangent. Okay, now notice it's negative 60 degrees. Okay, so that would be the same thing on my unit circle. Negative 60 degrees would be down here at 300, so it's going to be the equivalent of 300 degrees. Okay, as far as looking at the values.
So 5 pi over 3.
Yes, or 5 pi over 3 in radians if you want it that way. So I'm going to look at tangent again because I've got x and y values. So tangent of theta is negative 1 over negative 1, so that's just a positive 1. Tangent of theta here is negative root 3 over 1, so just negative root 3. And then over here, tangent of theta is equal to 1 over negative root 3, or negative root 3 over 3.
B.
So which one is tangent of 300?
B.
B. Because tangent there is negative root 3.
So, at negative 60 degrees is 300 degrees.
Because if I made it coterminal by adding 360, that's how I would get to that.
Okay, so we're
If you didn't have the unit circle in front of you, I would probably add 360 and look at it as the positive value just to see it. But since I had my unit circle sitting in front of me, I just looked at it. Yeah, I was just like, okay, well, minus 60 would be 300 because I only have positive values on my unit circle, obviously. All right, evaluate without using a calculator by using ratios and a reference triangle, aka use your unit circle. So 26, we have the tangent. We literally just did that. I'm not doing that one. I lied. We're going to do 28. Cosecant of 3 pi over 4. So I need to think about this because cosecant, secant, and cotangent are not on my unit circle. I need to think about this as 1 over the sine of 3 pi over 4. So what is the sine of 3 pi over 4?
2 over 2.
Yes. So then, keep change flip. I get 2 over root 2. Rationalize it. I get 2 root 2 over 2, which is just root 2.
So is all we're doing just finding it?
Yeah. The section the other day was just quadrant 1.
Oh.
This is now all the other quadrants basically in this section. 32. Cotangent of 13 pi over 4. So, obviously we don't have cotangent, so I need to flip it to be tangent. So 1 over the tangent of 13 pi over 4. Now, is 13 pi over 4 directly on our unit circle?
No.
No. So I'm going to go all the way around and I'm going to count this out now. I'm not going to count every single little pi over 4 here, but all the way around 1 full time is 2 pi or 8 pi over 4. Okay. So now I'm going to start counting because I'm going to what? 13 pi over 4. So I'm at 8 pi over 4 after 1 full time around. So this is 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4 is the same thing as 5 pi over 4. So what am I looking for, cotangent?
Yeah, so finding one.
So the tangent of 5 pi over 4 or 13 pi over 4 is 1. So this is 1 over 1, which is just 1. Now, the other thing I could have done is I could have found a I could have subtracted 2 pi from 13 pi over 4 and found the coterminal angle and then used that way instead of having to count. So if you want to use that method as well, you can do that. But I kind of like counting because, for the most part, counting is easier to me. But 34. Cosine of 17 pi over 4. So with this one, since we just counted with increments of pi over 4, let's do coterminal angles to find this one instead. Because cosine is directly on there, so I don't have to do any other conversion. So I'm going to subtract 2 pi, which would be 8 pi over 4. So 17 pi over 4 minus 8 pi over 4 gives me what?
16 pi, 8 pi, it's 11 pi.
9 pi over 4. Now that's still not on the unit circle, technically. So I'm going to subtract another 8 pi over 4. And I get pi over 4. So that tells me that this is the same thing as me looking at the cosine of pi over 4. Which is what?
2, root 2.
Root 2 over 2. Alright, any questions about those ones? Seeing if there's anything else in here we need.
It wasn't even a real weekend. It should have given us Monday off.
Next week you have Monday off.
I know, but we needed it this weekend.
At least you get 3 full days off though, although don't y'all have a tournament?
Oh yeah, we do. And I had to get up early.
I have to get it early.
I'm going to Stephen's church, so I have to get up at like 4 a.m.
Alright, 44.
Like Franklin, Virginia. When we play Southampton.
Find the cosine of theta and the cotangent of theta if the sine of theta is equal to 1/4 and tangent of theta is less than 0.
I thought. Never mind. I'm not gonna say anything because I'm gonna sound stupid. So I thought tangent can't be
Let me just say what it
negative.
says.
I thought like an angle measure can't be negative.
The whole value of tangent is theta. Tangent is negative in quadrants 1 and 3. Or, I mean, sorry, 2 and 4. It's positive in 1 and 3.
You can't have like negative angles in a triangle,
Right.
but in the circle in relation to the quadrants.
This is just telling me that the value of tangent is negative. So this tells me that I either have to be in quadrant 2 or quadrant 4.
Okay.
Now, sine is positive, right? So that means that
Quadrant 2.
that has to either be in quadrant 1 or quadrant 2. For both of these things to be true, the only place that they're both true is in quadrant 2. So that means that this has to be in quadrant 2. So that means essentially it has to be up there. All right, so sine is opposite over hypotenuse, so that means that this is 1 and this is 4. And then I need to find the other side. So a is equal to the square root of 4 squared, which is 16, minus 1 squared, which is 1.
15.
So square root of 15. That breaks down into 3 and 5, so I can't take anything out. So this is just the square root of 15. So now that I have that, I can find cosine of theta is equal to what?
The square root of 15 over 4.
Square root of 15 over 4. And cotangent of theta.
Opposite over adjacent. Adjacent over opposite.
Root 15.
Root 15.
Yep.
May I use the restroom?
So tangent would have been 1 over root 15, and so then cotangent is root 15 over 1. And so they just wanted us to solve for these two. Obviously, if it wants other ones, you can find them once you have that information. There's something wrong in this problem. I'm going to see if you can find it.
The circle's not complete when you circle your answer.
No. I will give you 60 seconds to see if you can find the problem.
Do you think that the square root of 15 is supposed to be, wait, it can't be negative, can it? Because it's backwards.
You wrote it in the wrong quadrant, right?
No, that's quadrant 2.
Oh, you weren't finding the
Shouldn't 4 be the
you weren't finding the
hypotenuse?
hypotenuse. Root 15. You
The
did the
Pythagorean
problem
theorem
wrong
is wrong.
because 4. Yeah. Wait.
Because 4 should be
what?
the hypotenuse, right? So that's what you're
4
solving
is
for.
the hypotenuse.
You did the problem as if.
It's supposed to be setting.
No, it's not something like that.
Oh,
Which
no,
one
so
is-
yeah,
What
No,
corner
you
is
might be-
theta?
Sine is. No, you
We
were-
didn't put like a corner of theta.
That's not the problem.
Yeah,
But
it is
if-
because like wherever you put
Oh,
theta,
it should be
determines
one.
the outcome.
No.
Yes, it is.
Where is
squared plus
theta?
b squared
Daniel,
equals
which
the
corner
square
is
No,
theta?
I think it's something with the Pythagorean theorem.
Shouldn't
I
it-
know,
yeah,
but if I knew
shouldn't
what
it be-
theta was, I might be able to
5
figure it out.
seconds.
Plus b squared equals c squared.
All right, final answer.
Or.
Shepard's not here.
You did
Oh,
the
well.
Pythag wrong,
Yeah,
right?
you did.
It's supposed to be 1 squared plus 4 no.
Oh, the iPad
plus-
turned off.
1 squared plus
Alright.
b squared equals, the square root of whatever 4 is. And then that's 2, so then b would be, I don't know.
Nope, I just manipulated the formula without doing it. That's why it's this way. This is the hypotenuse minus the side. This is supposed to be negative.
I did say that, but I wasn't sure.
If tangent is less than 0, then cotangent also has to be less than 0. And this is in the negative direction here, so that should have had a negative on
Why
it.
did you say that, Shirley?
I said it to you and Daniel, and neither of you answered me. I was like, is that supposed to be negative? I'm not sure.
I look, he wasn't listening.
Yes, I'm amazed the restroom.
All right, problems for this section.
Dude, then should the 4 be negative too?
Nope, hypotenuse can't be negative.
This is 4.3, right?
okay, Shepard. I have a piece of paper for you.
Thank you, Mason.